Hi everyone, we are still in chapter 1 matter for the subtopic 1.2 mole concept part 2 concentration. So in this part 2, you will learn about the empirical formula and molecular formula. How to get the empirical formula? From the mass composition and combustion data. Okay, let's see the example of the mass composition. A sample of hydrocarbon contains 85.7% carbon and 14.3% hydrogen by mass. So it gives you sample of hydrocarbon, shows that the sample contains hydrogen and carbon. And it gives you the percent for the carbon and percentage for the hydrogen. And its molar mass is 56 gram per mole. This is the molar mass. And the question, it asks you to determine the empirical formula and molecular formula of the compound. So you have to assume mass of the hydrocarbon as 100 gram because it gives you the percentage of carbon and hydrogen. So you can assume mass of the hydrocarbon as 100 gram, 1000 gram, or any amount. Okay, because it already gives you the percentage. To make it simple and easier for you to calculate the mass of the carbon and hydrogen, so you assume mass of the hydrocarbon as 100 gram. Next, you have to form table, which is it has mass, and you noted the unit of the mass. And here is the element carbon and hydrogen, and this is the value of the carbon in gram, and same for the hydrogen. Next, you have to show the calculation for the number of mole, carbon and hydrogen. And you have to calculate the simplest ratio, which is the you divide the mole, okay, with the smallest mole from the both of the elements. So here the smallest mole, we can see that carbon. So simplest ratio for the carbon, you can get it is 1 and hydrogen is 2. Then the empirical formula is CH2. Next, to calculate the molecular formula by using this formula, and we refer to the mole times to the empirical molar mass of the empirical formula equal to the molar mass of the molecular formula. So the empirical formula is the CH2. You put in the bracket and outside is the N, and then here is the molar mass of the molecular formula for the sample. So the molar mass molecular formula for the sample is 56 gram per mole. Then you can calculate the N value. You will get N is equal to 4. So the molecular formula is C4H8. Okay, when you substitute the value of 4 in this formula, then you can get the molecular formula is C4H8. Okay, next, combustion data. Example, combustion of the 2.3 gram of an organic sample X. So it gives you the mass for the organic sample, 2.3 gram, yields 3.30 gram carbon dioxide and 1.80 gram of the H2O. So it gives you the mass for the product of the combustions. We know that combustions of the hydrocarbon, it will produce carbon dioxide and H2O. So the question is, it needs you to determine the empirical formula. Okay, so because it produces carbon dioxide and H2O, it shows that the organic sample contains elements of carbon, hydrogen, and oxygen. So, how to get mass of the carbon, mass of the hydrogen, and mass of the oxygen? From the product, you can see that carbon is in carbon dioxide and hydrogen is in H2O. Oxygen, okay, it is in carbon dioxide and also H2O. So let's see how to get the mass of the carbon from the carbon dioxide. Okay, mass of the carbon equal to the mass of the carbon dioxide given over the molar mass of the carbon dioxide. So the molar mass of the carbon dioxide, you can refer to the table relative atomic masses, times to the molar mass of the carbon, which is in formula of the carbon dioxide, there are only one carbon, so 12 gram per mole. For the mass of the hydrogen, you can get from the H2O, which is mass of the H2O given 1.8 gram divided by molar mass of the H2O times to 2 gram per mole. Why it is 2 gram? Because in the formula of the H2O, there are 2 hydrogen. So you will get the mass of the hydrogen 0.2 gram. To get the mass of the oxygen, because the sample of the organic X, okay, it has carbon, hydrogen, and oxygen. Now you already have the mass of carbon and hydrogen. So mass of the sample is 2.3 gram. Then you 2.3 minus to the mass of the carbon and hydrogen, then you will get the mass of the oxygen is 1.2 gram. Next, okay, after you get the mass of the carbon, hydrogen, and oxygen, then you can calculate as usual, okay, by using this table, okay, number of mole, and get the simplest mole ratio. So here you can see that we do not take this number, okay, the first simplest ratio given here, okay, because for the hydrogen, okay, the simplest ratio is 2.667, so you cannot round off it to 3, so you need to times some number, okay, to get it near to the whole number. So here when it times to 3, okay, you will get that it almost to the whole number. So this is the simplest ratio, okay, for the sample X, and it is C3H8 and O3. Alright, remember, do not round off the value, okay, if the value is not near to the whole number. For the example 2.8, okay, still cannot round off to the 3, okay, you have to times some numbers, okay, and the result must be near to the whole number. Okay, next, concentrations. There are 5 items, okay, that relates to the concentrations: molarity, molality, mole fractions, percentage by weight, and percentage by volume. Okay, molarity you have covered, actually you have covered in part 1 of the 1.2, okay, but here, okay, you will learn it more detail, okay, about the molarity, and we will see some of the example, okay, for the questions. Okay, let's see what is the molarity. So molarity, we refer to the number of mole of the solute dissolved in 1 liter of the solutions, and the unit is mole per liter, or mole per dm cube, or molar with the bit letter of m. Okay, this is the unit for the molarity. So what actually is the solute? Solute is we refer to the substance that dissolve in the solvent. So solute mixed together with the solvent, it will form solution. Alright, then this is the molarity, the formula of the molarity. Mole of the solute, the unit for the solute is the mole, and then volume of the solution must be in liter. Okay, so this is a unit for the volume, you should know. Okay, 1 liter equal to the 1 dm cube, 1 milliliter equal to 1 cm cube, and if 1 dm cube equal to 1000 cm cube. Let's see the example. A student prepared a solution of the sodium chloride by dissolving 1.461 gram of the sodium chloride in 250 ml volumetric flask. So what is the molarity of these solutions? Okay, you have the mass of the NaCl, which is the solutions is NaCl solution. It formed from the solute. The solute is NaCl and water. Okay, this is the volume of the water, 250 ml. To get the molarity of the solutions, you need to calculate the mole of the solute. Okay, because it gives you the mass of the solute. Then by using this formula, you find the mole of the solute and you substitute in the molarity formula. Okay, make sure that you convert the volume given into liter. And you substitute in the formula, you will get the molarity is 0.1 molar sodium chloride solution. So this is the molarity for the solution. Molality. Molality, the number of mole of solute, still same as the molarity, the number of mole of solute, but in molarity it is per volume of the solution. For the molarity, it is per 1 kilogram of the solvent in a solution. So per mass of the solvent, not solution. And the unit is mole per kilogram or molal or small letter of m. So this is a formula of the molality, mole of the solute divided by mass of the solvent must be in kilogram. Okay. Calculate the molar concentrations of the ethylene glycol with the molecular formula given here. Okay, containing 8.4 gram of the ethylene glycol in 200 gram of water. Molar mass of the ethylene glycol is 62 gram per mole. So, ethylene glycol solution, it contains 8.4 gram ethylene glycol. This is a solute. And 200 gram of water, this is a mass of solvent. Okay, because it gives you the mass of the ethylene glycol, so you need to find the number of mole of ethylene glycol, mass over molar mass. So this is the mole of the ethylene glycol. Then to get the molality, okay, by substitute the value in the formula of the molality and make sure that the mass of water given 200 gram convert to kilogram, which is divided by 1000 gram. So here it is 0.2 kilogram. Then the answer is 0.675 mole per kilogram. Mole fractions ataupun pecahan mole. It is the ratio of the number of mole of one component to the total of number of mole present. So let's say you have more than one component in the mixture. Okay, so the mole fractions, for the example, we have the component A and the symbol for the mole fraction is X and subscript of the A. Okay, and mole of A divided by total mole, which is, okay, this is a number of mole of A represent for the component A, and total we refer to the mixture of the mole. For the example here, let's say if the solution contain A, B and C, so the mole fractions of A is the mole of A divided by total mole of A plus dengan mole of B and plus mole of C. So you should remember that because it is mole fraction, so no unit for the mole fraction. When you get the answer, okay, there is no unit for the answer. And mole fraction always smaller than 1, okay, because it is fraction, right? So it always smaller than 1. And the total mole fraction in the mixture is 1. Okay, when you total up all the fractions, okay, you will get the total is equal to 1. So let's see the example. A sample of the ethanol contains 200 grams of the ethanol and 150 grams of water. Calculate the mole fractions of the ethanol and water. So here there are two components, ethanol and water. So to get the mole fractions, because it gives you the mass, so you need to find mole for both of the component. So for the ethanol, okay, this is a mole for the ethanol and this is a mole for the water. Then by using the formula of the mole fractions, you have to note that if it gives you the component, you cannot use A, B, C. Okay, you have to specify what is the component given in the question. For the example here, it gives you the ethanol. So mole fractions of the ethanol equal to the mole ethanol divided by total mole of ethanol and water. So you will get it is 0.3429. So this is a mole fraction for the ethanol. To get mole fractions of water, as we know that the total mole for the mixture equal to 1. So here there are two components, ethanol and water. So total mole fractions of ethanol and water equal to 1. To get the mole fractions of water, 1 minus to the mole fractions of ethanol. Then you will get the mole fractions of water. Alright. Next, percentage by weight. It is the ratio of the mass of the solute to the mass of the solution multiplied by hundreds. Okay, this is the formula, which is to get the percentage by weight. W we refer to the weight, okay, mass of the solute divided by the mass of the solution. What is the mass of the solution? Solution we refer to the mass of the solute plus with the mass of solvent, and then times to 100 because it is percentage by weight. For the example, we have a sample of the 0.892 gram of the potassium chloride is dissolved in 54.3 gram of water. So the solute here is the 0.892 gram of the potassium chloride. This is a solute and this is a solvent, water as a solvent. So what is the percent by mass of the potassium chloride in these solutions? Then you just substitute in the formula, okay, the value given, and then times to 100, then you will get the percentage is 1.616%. Okay, or the other words, it shows that mass, this is a percentage by mass for the potassium chloride from the solutions. Okay, the rest is percentage by mass for the solvent. Okay, percentage by volume. The ratio of the volume of a solute to the volume of the solution multiplied by 100. This one is the volume of the solute. So the formula quite similar with the percentage by mass, but this one it using volume of the solute and volume of the solution. And noted here, okay, it is used for the liquids and gas. For the example, there are 350 cm3 sample of vinegar, okay, contains 2.10 cm3 of the ethanoic acid. So here, sample of vinegar contains means that the ethanoic acid is the solute. Okay, and the sample of vinegar is the solution. So what is the concentrations of the ethanoic acid by volume? By using the formula, okay, given of the volume solute, this one 2.10 cm3 over 350 cm3. So you will get the percentage by volume is 0.6%. You can use any unit of the volume as long as the unit for the volume solute same as the unit for the volume of the solution. Okay. That's all. Thank you.